Alright guys, welcome to 11.3 and 11.5 combined notes. We are not doing 11.4, we skipped that section, so 11.3 and 11.5. 11.3 is a lot more definitions. So what we went over in these notes were different types of sampling methods. So to start out, I just went over what was a random sample. So something where everyone has an equal chance of being selected would be a random sample. Then we went over the different types of sampling methods. Now a lot of these can be very biased, so it just depends on the situation as to which one you would use. So a self-selected sample would be members of a population volunteering to be in a sample. Okay, so this might look like you filling out a survey and you're allowed to fill out the survey but not forced to, something like that. Systematic is a rule used to select members of a population. It'd be something like every other, every third, every 100th person. It's just some sort of rule to pick out the members of the population. Your stratified sample and your cluster sample, the next two, are often confused with each other because both of them require division into smaller groups. Your stratified sample, though, you start with your smaller groups and then you are randomly selecting from those groups. Your cluster sample, once you have it into groups, you're selecting all of the members of one or more of those clusters. Okay, so biggest difference, stratified should say randomly, cluster will not. Then you have what's called a convenience sample, where only members of a population who are easiest to reach are selected. So people that live close to me, people that work close to me, those would be convenience samples. Okay, so for example 1, we just wanted to go through and decide which type of sample we described. So we want to determine whether people in the neighborhood like the new social media website. So for the first type of sample, I asked all of the neighbors in the block where I reside. Okay, so that is a convenience sample because it is nearby. Okay, that one's a convenience sample. The second one, you randomly select a neighbor from each block in the neighborhood. So you're dividing them into blocks and then randomly selecting. So that is an example of a stratified sample. Okay, the next one, you email a questionnaire to each neighbor and only use the questions that are returned. That would be a self-selected. That's the one where they're volunteering. Okay, on the next one it says bias. A bias is an error that results in a misrepresentation of a population. So something that's affecting your data. You can either have an unbiased sample or a biased sample based on whether it is a good representation of the population or a bad representation. Okay, so unbiased would be a good representation. Biased either overrepresents or underrepresents your population. Okay, so example 2, it says identify the sample and explain why the sample is being biased. So the first one says a principal asked the students at one lunch table about the quality of food in the school's cafeteria. So my type of sample would be a cluster. Now you think about it, little groups would be your cafeteria tables. And this is biased because the people at the table probably don't have different opinions from each other. Okay, so he's asking people already in the cafeteria, or maybe you say all their friends, so they might all have the same opinion. Okay, lots of different options. It's good handwriting right there. Okay, the second one says, a sports announcer wants to know how often people in the town attend community sporting events. She asks every 10th person in attendance at a local soccer game. So every 10th is telling me this is a systematic sample. And it's biased because they're already at a game. Okay, so if you want to know about an entire town, then you should ask the entire town, not just people who are already at a sporting event. Okay, the last thing we're going to talk about in the 11.3 notes is different types of data collection. Now, a lot of these should be common knowledge to you guys, especially if you think about it in terms of a science experiment or observation. Okay, so your experiment is something that you're doing in order to collect data. Okay, so you're imposing either a treatment or some sort of situation in order to collect data. Your observation, you're just observing. You're looking at individuals, but you're not changing anything. Okay, so you're just looking. Your survey is an investigation, so think about this as maybe a paper survey, an oral survey, something you're just asking questions. And then you have a simulation, which uses a model to reproduce the conditions of a situation. So something in order to predict the future. This could be in-person simulation, could be a computer simulation. Think about like computer-generated kind of things. Those would be simulations. Okay, so for example 3, I want to identify the type of data collection used in the situation. So the first one says, a teacher records how many students enter the classroom and turn in their homework before sitting down at their desks. So this one would be observation. Okay, the second one, a manager uses a computer program to predict how many defective products can be expected on a particular assembly line. So that computer program is a simulation. And the last one, members of a student council at your school ask every 8th student who enters the cafeteria whether they like the snacks in the school vending machines. So this is an example of a survey. Okay, we are going to move on to 11.5 notes now. So different days worth of notes. Okay, 11.5, we went into more numbers and we talked about margin of error. Okay, so first thing we're going to talk about is just different statistics, one being descriptive, so it involves an organization or a summarization, and the other being inferential, so using a sample to draw conclusions about a population. Okay, that's what we're going to focus on, is using samples to draw conclusions. So my first example says a cafeteria manager wants to predict the number of chicken sandwiches that will be sold when students can choose chicken sandwich or a turkey burger. 7 cafeteria workers conduct surveys of randomly selected students. The students are asked whether they will buy a chicken sandwich. So this is a yes or a no. Are they asked to buy a chicken sandwich? And the results are shown in the table on the next slide. Okay. Based on the results of the first 2 sample surveys, so you're just looking at the first 2, do you think there will be more chicken sandwiches sold than turkey burgers? Okay, so if you look at just those, it looks like the majority of people are saying yes, they would buy a chicken sandwich, so I would say yes, more chicken sandwiches would be sold. Okay, the second part asks you to look at the entire table, so now look at all of your yes votes. Based on the results, do you think there will be more chicken sandwiches sold than turkey burgers? Okay, now if you look at the rest of those percentages, it looks like more turkey burgers would actually be sold, so therefore I would say no to the chicken sandwiches. Okay, then we have what's called a population proportion, okay, and that's pronounced row, like rowing a boat. Okay, population proportion is the ratio of members of a population with a particular characteristic to the total number of members. So just think about that as a fraction, those with the characteristic over your total number. Okay, and then we also have the sample version of that, so those members in the sample with a particular characteristic over total members of a sample. What we're going to focus on for the rest of these notes is what's called a margin of error. So how much error are we making going from the sample to the population? Okay, so for example, if 40% of people in the poll favor a new tax law, then and my margin of error is 3.5%, then somewhere between 36.5% and 43.5% is what the population would likely favor in the new tax law. Okay, so we're just using our sample to predict our population. Okay, so in order to find the margin of error, what we do is we take the size of the sample, And we plug it into this formula. So we have plus or minus 1 over the square root of your sample size. So what you're doing is you're taking whatever your ratio was and subtracting your margin of error, and then you're taking that ratio and adding your margin of error. Okay, that's going to give you the interval for your population. Okay, this is just a little added information here, and I will let you guys, if you want to ask me questions or pause on this video, this is how to find mean, median, mode, range, your interquartile range, your variance, and your standard deviation on your graphing calculator. I'm not going to go through that with you in the video, so if you want to practice that when you see me, that's great. Otherwise, make sure you pause and you practice this on your own. Okay, so for example 3, it says the number of text messages sent each day by a random sample of 30 teen cell phone users are shown in the table. Estimate the population mean. Now, what you can do is either use your calculator or find your mean by adding them all up and then dividing by the 30. You would get 60.4 for your mean. And in order to find your margin of error, remember we do plus or minus 1 over the square root of that sample size, which is 30. So that's going to give me some margin of error about 18%. So plus or minus 18.26%. Okay, and then it says estimate the population proportion of those who send more than 70 text messages each day. So go through the table. Feel free to pause this anytime. Go through the table. Count up how many send more than 70 text messages per day, which you would get 8. And then that's over 30, which is about 27%. So about 27% of the population would send more than 70 text messages each day. Okay, the last slide is using that same information, okay, but now it's saying I want to determine the margin of error based on different numbers. Okay, so say I sample 250 teens, okay, I'm going to find my margin of error is about 6.32%. Okay, which means that the interval containing that, I'm going to take that 27% from the last slide, and I'm going to add 6.32 and subtract 6.32. So I get 20.68 to 33.32%. So somewhere in between there would be my population proportion. Okay, the next one says I'm going to do an estimate of those who send fewer than 50 text messages. So go back to your table, feel free to pause, count up how many send fewer than 50 text messages. You should get 8 over 30, which happens to be the same percentage. Okay, then we're finding our margin of error based on 500 teens, which ends up being about 4.47%. Okay, which means my interval, so I'm adding it to this 27 and subtracting it from that 27, would be 22.53 to 31.47%.